research and regulatory needs for the next 20 years. You know, I was thinking some time ago that, you know, we often have, or almost always have, seminars that are focused on one particular research problem, one particular issue in Minnesota water, for example, whether that's stormwater research or phosphorus or some particular pesticide in water. And you know, we thought that it would be good to open this up, one of our seminars, to look at, you know, more broadly, you know, what those research and regulatory needs are going to be for us, not only here in the state of Minnesota, but maybe even more broadly, even more, you know, nationally speaking, as we move forward. And so today we have three people with us who, you know, through their work and experience, I think are going to be able to tell us some really interesting things about that based on their perspective and experience. We have Alan Roberson from ASDWA, who is based in Washington, D.C., with us here this morning, and Carrie Jennings from the Freshwater Society, and Ryan Noe from the University of Minnesota, each of whom are going to be speaking about their particular focus and their particular expertise, and trying to get us to think about things a little bit more broadly, as I said, about what we need to be doing going forward. And then after each of them give a 15-minute presentation or so, we would like to just open that up for a Q&A and a discussion, and see what all of you out there think, and see what kind of questions you might have of our panelists. So with that, it is a real pleasure to open up our consortium this morning with Alan Roberson, from the who is executive director of the Association of State Drinking Water Administrators, based in Washington, D.C. He has over 30 years of experience providing technical and policy input on all aspects of the drinking water regulations, as well as working with congressional staff on potential amendments to the Safe Drinking Water Act. And he works closely with the Environmental Protection Agency and Department of Homeland Security on ensuring the safety and reliability of water systems. May I recommend to everyone out there that you take a look at Alan's 2011 paper, 10-year-old paper now, that he authored in ES&T. And the title of that is, "What is Next After 40 Years of Drinking Water Regulations?" It is really an excellent overview and a brief review of the Safe Drinking Water Act that I just learned a ton out of, and I'd highly recommend that. It's a compelling and a very readable history of the EPA and the Safe Drinking Water Act, leading to the development of the contaminant candidate list and regulatory determinations. And in that paper, I thought what was really interesting, even then, Alan asked, is the current regulatory process appropriate for the next 40 years? Saying that we had basically picked the low-hanging fruit through the previous 18 previous drinking water regulations. And I'm going to leave it off there, Alan, and I'll let you take it from there. Welcome to our seminar series and our consortium.
Well, thank you, Mark, and thank you for tracking down that 10-year-old paper. You know, it's just always interesting to see that still has legs, and some of the questions I asked then are still relevant today. So, and again, thanks for the opportunity to present to this group. It's nice to be able to step back and present a little bit on the national perspective, and again, looking forward, given my years of experience in the water sector. And so, just have a short presentation today. I want to talk a little bit about ASDWA and a little bit about myself for those that may not be as familiar with it, because we're on the drinking water side. There's an equivalent association on the for the wastewater folks, the Association of Clean Water Administrators. And then I'm going to talk a little bit about some of the water research that, you know, my perspective on it, looking at water quality which is primarily what I work in drinking water, and then it's increasing the number of chemicals. What we're good at as far as with that, and then some of the needs and gaps, again, this forward look. I do think I got to talk about water quantity a bit, and not just focus on water quality from the drinking water side. And then I want to address, at least mention cybersecurity, and then provide some positive paths forward about things to consider. But before I do that, for those that might be old enough to remember Monty Python's Flying Circus, I thought I'd talk for a minute about the brood X cicadas. So this is a brood that is, cicadas are all over the country, but there's about 20 different broods, but brood 10, or brood X, is on a 17-year cycle and is very common in the mid-Atlantic area. So what you're seeing here is a maple tree in my backyard, and it's not like I live in a farm. I'm on a quarter-acre lot in a subdivision that has about 20 or 30 feet of these original trees in the back. And on the left, you can see a handful of cicadas working their way up to the tree to then plant their eggs in the branches as it goes out. And then at the bottom are what I call the shells or the husks. So they're down on the ground for 17 years. They come out and leave this husk behind and molt. You know, somewhere we might see like a butterfly coming from you know, their process. And you can see how many came out of this one maple tree. So they're really in all the trees in my backyard, but they particularly like this maple. And so we've had about 3 weeks of the spaceship hum, if you can remember Close Encounters of the Third Kind. That's what we're hearing. It's kind of on the downslope now, but again, because it's so unique, and we have a lot of, I think, folks on the phone that are used to working in the environment, being outside, collecting water samples. This is something we're having to contend with, like on walks in the neighborhood and even playing tennis on Sunday outdoors. They land on you occasionally, or, you know, fly on the net and things. So it's something we've been having to live with, but it's quite interesting. And in another couple of weeks, they'll be gone. So with that, I'll talk a little bit about ASDWA. We're a national, nonpartisan nonprofit that represent the drinking water agencies across the country. So we've got all 50 states, 5 of the territories, DC and the Navajo Nation, which makes it pretty unique for a association, because we're not trying to grow our membership. We've got everybody, and everybody's pretty active. In fact, when I first started at ASDWA 4.5 years ago, the president was Randy Ellingbo, formerly of the Minnesota Department of Health. And so it just rotates around, but Randy happened to be actually the one that called me and offered me the job a little over 4.5 years ago. So again, the real members, when we send out emails, they're the heads of the program, but we have a lot of staff that participate. We have committees and work groups, and so we need the technical staff. And again, we try and facilitate this dialogue from the state programs to EPA. And so literally I'm, you know, emailing EPA every day, depending on the issues, different people. And then, you know, we do meet with them once we get back to being in the office. And same thing with members of Congress, because there's a lot of interns and young folks that don't know the ins and outs of drinking water. And again, it's a small staff. We have 6 folks, including me. The top picture, we just moved into a new office actually in October last year because our lease ran out. So we just moved across the street into some new office space. And if you're wondering what the funny picture is below that, I went to Georgia Tech to get my engineering degree years ago and went back for homecoming, and that's the mascot Buzz. So the team's called the Yellow Jackets. And we went down for homecoming. It was a cold day. And so I had a hat. And so Buzz wanted to take a selfie with me, but had problems with the phone, with the gloves that he wears, you know. So I was laughing because it took him longer to do the phone than it normally does me. And so it kind of made me laugh. And I think it's a good picture. And brings back my links to Georgia Tech many years ago. So again, now jumping into the meat of the talk, I just think that our water sector is under-researched. We don't have, I mean, Minnesota is unique in that you've got the fund to be able to do dedicated research and look at emerging contaminants. But, you know, frankly, there are not many states, if any, that really have that kind of funding and research program. Primarily done by groups like the Water Research Foundation, EPA, universities, and others. But again, a lot of that funding has stayed flat for decades, and you have flat funding for 20, 30 years, and your funding's essentially been cut in half or more. So we see a lot of research on more what I'd call the engineering or chemistry side of water quality. A lot of treatment research. There's a lot of treatment now, research going on PFAS, how to take them out, what kind of carbon. I know that's an issue in Minnesota with the 3M plant. And same thing with analytical methods. The chemists are always good about going down the lower and lower levels. When I started at AWA back in 1991 and started working in drinking water, I worked in their DC office for 25 years. You know, we had just gotten past parts per million going to parts per billion. And now we're routinely seeing parts per trillion for the analyses for PFAS, and it's going down another order of magnitude to parts per quadrillion. So they're ahead of the rest. You know, that's way ahead of what, you know, treatment's designed for. But we're not keeping up with the health effects research. So, you know, what does it mean if you have PFOA at 5 parts per trillion? You know, I'm not really sure. And then it's not keeping up with the increasing number of chemicals. And so that's really the problem, is it's hard to make informed regulatory decisions when your health effects information is lacking. You may have treated for information, you may have the cost of the treatment, the capital and the O&M, you may know what it costs to analyze, but it's hard to really get a good handle on the benefit. And then the public just doesn't understand all this. You don't understand the research itself. I'm actually on the board of directors of the water system here in Northern Virginia. And my colleagues, I send them health effects studies and they say, I don't understand it. I'm like, well, I sort of do, but it's not really something the public can digest. And so they just want to have safe water without any of the jargon. And that's a challenge sometimes. So what we're good at, we're good at building stuff. And so this is a picture of a transmission main being built in my area. And so, you know, we're dominated by engineers and scientists. And so we're good at making the water safe to drink, distributing it, and then also cleaning it up on the back end for the environment. And one reason I like working in this sector is that, you know, we're wearing the white hat. We're protecting public health, we're protecting the environment, and that's a core value. And that's, you talk to people that work in this sector, that's why a lot of them got into it, is that they're really protecting public health. And then, but the downside, it's also the silent service. It's not as good at marketing, not as good at branding to the consumers who consume the drinking water and then want to be able to use the environment effectively. And then this tweet came out about Kurt Vonnegut about, again, everyone wants to build and nobody wants to do maintenance. And so that's one of the challenges that we're seeing in the sector, is that, you know, you can have funds available, state revolving funds, to build the plant, but are you going to have a rate base to be able to operate and maintain it properly in the future? So here's a slide about the needs and the gap. So anyway, I've heard some people ask, you know, hey, the federal oversight of water quantity and quality scattered a bunch of different federal agencies. Do we want one that would make it all, you know, together uniform? You know, I don't think so. I'm not real happy with the diversity of the programs, but in general, they coordinate pretty well. And the idea of creating a new agency that has oversight over everything across the country just kind of boggles my mind, given how I've seen bureaucracy operate in DC. We need to get ahead of these new and emerging contaminants. And sometimes it's new contaminants like PFOA and PFOS, or the other PFAS, you know, not just those two, which are the common ones. And then we have some that are emerging, or we know about them and we're sort of controlling them, but we have new health effects that cause concern. And the one I point to there is manganese. People have been working on manganese because of the aesthetic effects, but now there are some neurological effects that are creating concern. And so again, here's one that was kind of around, but now has emerged to a higher priority. And then how do we keep these contaminants out of the water supply? You know, our use of TSCA, the Toxic Substances Control Act, is just not optimal. From my point of view, it's not doing the job of keeping these things out of the environment, so it doesn't hurt the fish and the frogs, and doesn't place the burden of the treatment cost on the drinking water utilities. And again, the gaps. It's a silent service. You know, we don't tell the good news stories. It's hard to say, hey, today we produced, you know, this is the utility that I'm on the board for. Hey, we produced and delivered 200 million gallons of water to 2 million customers in Fairfax County, Loudoun County, and Prince William. And tomorrow it's going to be 205. And, you know, Saturday it's going to be 210 because it's getting hotter and people are watering the yards more. So we're not getting it. It's not really a very like newsworthy story to say, hey, we did a good job today. So you see more coverage of what I call the incidents. And this is just a few of them. the one that really everyone's heard about is the lead problems in Flint, Michigan. But there are lead problems in other cities. Pittsburgh has a lead problem. Newark has a lead problem. We think there are lead service lines in 8,000 to 10,000 water systems across the country. It's a problem. Flint got all the news. Just a couple of newer ones, Naegleria fowleri, which is a brain-eating amoeba, was found to be a problem in a water park in Lake Jackson, Texas. The water park was supplied by the public water system, so that created some issues for the system and for my member, Texas CEQ. And then there was a fair amount of publicity about the cyber hacking in Oldsmar, Florida. And now we've heard about Colonial Pipeline and JBS, the meat packer. So a little more about, what I see, some of the needs. We need to coordinate research and really leveraging the university research. I'm glad to see Ryan on the panel today because, again, it's a way to try and leverage the expertise of the professors and get what I call value-added labor from the grad students. So you get smart people that are doing good work at a value-added price. And how do we prioritize these new and emerging contaminants? How much effort do we spend on chasing down PFAS versus fixing manganese? And again, I think Minnesota's done a great job with this through their program. In fact, I've looked at the progress of it, and there's some really solid research and some processes that have been put in place that might be worth, moving up to the national level. And again, I mentioned this before, we've got funding gaps at every level. EPA has had funding for two decades. Most states have no really research funding. Again, Minnesota is unique. Some of the bigger states, California and New York, do a little bit. The water systems don't do a whole lot on their own unless they're running a pilot test or running a pilot plant. They mainly work through the Water Research Foundation, which is the umbrella association for research on drinking water, wastewater, stormwater, and water reuse. Universities do great research, but they're dependent typically on funding from others, from foundations or from grants from federal agencies or otherwise. Some of the manufacturers have a reasonable R&D program, but it's all dependent on what they think the return's going to be. They look very closely at their return on investment. So I'm going to switch now to water quantity. And I always like looking at this drought map that comes out of University of Nebraska at Lincoln, because you look at the Southwest, it's just like, wow, you got all this extreme and exceptional drought. I think California has 70-some% of the counties that are either in extreme or exceptional drought. And that's just an amazing statistic. I'll talk a little more about that in the next slide. So again, it varies considerably based on location. So again, you saw that the Southwest is in this extreme, exceptional drought. There's some up in the upper Midwest. North Dakota was in there too. But again, you look here in Northern Virginia, the two airports in our area, Reagan and Dulles, pretty normal. We've had we had about a 3-week dry period, but now we're getting kind of our normal cycle, which is rain about every 3 days. So it depends on how much we get. And then the extreme weather events that you're going to see will also vary based on location. And we're seeing that here in Northern Virginia. We're getting the same amount of rain. We're getting it less often in more intense storms. And the picture I have here is from the city of Houston and the ice storm that they had earlier this year. We lived in the city of Houston before we moved to this area in 1985. And you just don't see things like this. They've got no equipment, zero. And the problem is that when they had this ice and snow, then it stayed cold. So the roads stayed like this for several days, and that created a lot of problems. So that's just one, but you have droughts, floods, tornadoes, hurricanes. We've had a storm here called the derecho, which is an intense line of thunderstorm, and it has a tendency to take out trees and power lines. So when we had the last derecho, we had pretty extensive power outages. In some cases, took a while. I think we were out for 3 days here, but one of my colleagues was out for a week because he was kind of on the end of the line. It just took a while for the crews to get back there. So again, the long-term trends on your quantity is going to vary by location. And like I said, here it should be about the same, but we're going to have these more intense rain events over time. I want to talk about this new issue, cybersecurity. It's become big all of a sudden. SCADA systems are used throughout the water sector to move water around. You got pump stations and tanks and everything, multiple plants. The large systems are generally in decent shape. Again, Fairfax Water, budget of 200 million, 2 treatment plants, multiple tanks and pump station. They've got a really tight system. They've got a person dedicated to this. You got a lot more variability in these medium and small systems. So you've got some where the password's on the sticky on the control, and you got some where it's just the guys log in and there's no real security, no two-factor authentication. So again, we're seeing more of these distributed control systems and more ability to access it off your laptop or your cell phone to be able to check on the system or change. And then we're hearing more and more about these attacks and different hacks. A lot of them fly under the radar. You hear about Oldsmar, but I know of half a dozen, I'm sure there are more, where I've just heard about it through the grapevine. And just be aware, EPA is going to do something about it. They've been directed by the White House, and we've had conversations on what that might look like and when it's going to happen. So Mark mentioned my article from an ES&T from 2011, but a new one, more new one that came out in November issue of the journal AWA was this one about, again, trying to look ahead to our water future. And I wanted to talk about, this is my last slide. I want to talk about it for a minute, and then I'll turn it back to Mark to go to Ryan. So there's really no single path forward. It's hard to predict with any clarity. So you have to think about what the multiple possibilities are, and then how to maybe plan so you can adjust to each as they move forward. We really need to improve our communication to the public about the research needs, so we get support for that additional research funding. And again, that's across the board. We've got too many systems in the drinking water sector, over 50,000 community water systems. We need to consolidate and reduce that number. I think it's important to increase compliance with existing regulations. We've been hovering about 92% compliance with existing regs, and in some cases, we'll get more health benefit by improving that compliance with those regulations than developing a new one for something else. We've really got to increase the federal investment. That ties back into the second bullet of, get the public to lobby their members of Congress to appropriate more money. We need to increase innovation in the water sector. Again, being an engineer by training, you don't want to be the early adopter and have a spectacular failure. And again, we're protecting public health. People drink what they produce every day. And then we need to improve the water sector workforce. I'm part of what I call the silver tsunami. My retirement is closer than when I graduated from college. And it's at every level. You hear about it from the water operator workforce, but we got to have that at EPA. We got to have the state agencies. We have to have that at the consultants. And everybody, we need to attract these bright young people to participate in the water sector. And so we're going to have other presentations and a panel discussion at the end. There's my contact information if you want to send me an email or follow me on Twitter. And with that, I will quit sharing my screen and turn it back over to Mark.
Thanks a lot, Alan. What an interesting talk on a number of issues that are facing us. I was particularly struck by the slide you had in there about cybersecurity and water. That might foster a lot of questions that we have from the audience as well. Let me go ahead and, without any further delay, introduce our second speaker, Ryan Noe, who is here from the University of Minnesota. Ryan Noe is a senior scientist in the Science, Technology, and Environmental Policy area of the Humphrey School of Public Affairs at the University of Minnesota. I need to say that many of you probably did notice that our original panel of speakers included Bonnie Keeler from the University of Minnesota, who was at the last minute unable to make our consortium due to conflict. And Ryan bravely stepped into the gap to take over for Bonnie and bring perspectives on emerging issues and priorities in water. He manages projects on water and land use with a focus on co-developing actionable research with state agencies, conservation organizations, and policymakers in Minnesota. He also collaborates with the Natural Capital Project, where he contributes to the development of tools and methods to understand the biophysical, economic, and social consequences of changing land uses. He has a background in geospatial analysis, which he uses to model and map the public returns on investments from conservation activities and to prioritize future investments. One of the things that really caught my eye in his summary of his talk was that the federal standard for nitrate at 10 milligrams per liter may be great at preventing some problems in nitrate contamination and adverse effects like blue baby syndrome, but the growing epidemiological research that increase incidence of some diseases is also associated with concentrations below this federal standard of nitrate. Very interested in that, Ryan. Take it away, and interested to see what you have to say.
Well, thank you for that introduction. So yeah, I'm Ryan. I am a scientist in Bonnie Keeler's lab at the Humphrey School for Public Affairs. And the title of my talk is Developing Nitrate Attributable Health Damage Estimates for Public Water Supplies in Minnesota. But after I sent that to Mark, I realized that is a lot wonkier than I actually want to talk to you about today. So that's only going to be about 1/3 of my talk. The broader topic that I want to discuss today is how do we conceptualize and measure the value of water in Minnesota, and how does that relate to our policy decisions? So briefly, there's 3 topics I want to cover. The first is how do Minnesotans value water? The second then is how do economists value water? And that's where I'll talk about the recent advances we've been pursuing in nitrate attributable health damages. And then last, what are the gaps between those 2 perspectives and also the policy actions in Minnesota? So I'll start by talking about a survey that Bonnie did in collaboration with May Davenport's lab a couple of years ago now. And the goal of that survey was to try to address this gap where we have some economic tools for trying to value water quality, things like travel cost, hedonic pricing, avoided costs, health damages. But we wanted to get a perspective of, a non-economic perspective of what do Minnesotans think about when they think about the value of water? What are those relative priorities? And how can we then compare, how do those then compare to the economic metrics that have been developed? So I'm just going to highlight 2 questions from the survey. One of them is what's shown here, where we just gave them 17 different values related to water quality and asked them to rate each of them on a priority scale from not at all important to very important. So these were not mutually exclusive at all. They could rate everything as very important if they wanted to. So not surprisingly, I think drinking water that is safe and clean was the top value. But what was surprising a little bit to me was that, that was pretty much universal. 99% of people rated that as important or very important. More surprising to me was that future generations was a close second. And then things like habitat for native fish and wildlife and beaches and lakes for swimming and playing. Another interesting thing that came out of this work is I really expected there to be sort of an urban-rural divide, or at least some regional differences in the state with preferences and priorities for water quality, given the wide range of water quality and threats and resources that we find in the state. And we didn't really find that, at least with those top 4 that I highlighted just here. Drinking water and future generations were always first and second in all of the regions of the state. And then after that, it was a toss-up between habitat for native fish and beaches and lakes that are safe for swimming and playing. So there's this shows that there's a very clear preference for drinking water that's safe and clean. That's a very important value. Another way that we looked at this was from more of an economic perspective, where we had a question that said that there's this hypothetical pot of money in Minnesota. How should we prioritize funding from that funding source? But this time we only gave them 4 categories to choose from: safe drinking water, healthy fish and wildlife, high quality swimming and boating, and then reducing Minnesota's contribution to problems outside of the state. And again, not surprisingly, safe drinking water was the top priority. But I think the interesting thing to take away from this is that we can kind of put some numbers on this, that it's between 40 and 45% of the budget is what the respondents to the survey, which we had about 1,400 respondents, and it was a representative survey. that they value safe drinking water really highly, as evidenced by the first question, and they're willing to pay for it, as shown by this question. So then now I want to just compare this a little bit to some of the economic metrics that have been developed in the last couple of decades. So there's, as I mentioned, there's a lot of those, and I'm just going to focus on one here. This is work that Bonnie led back in 2016 or so, where it wanted to look at what are all the different social costs that could be come from nitrogen pollution. So one of the ways that you would do this when you're looking at water quality is you would say, well, what are the avoided costs that a treatment facility or an individual wouldn't have to pay if they didn't have this problem that they needed to treat to begin with. So that's things like avoiding drilling new and deeper wells, avoiding installing reverse osmosis, avoiding buying bottled water if you're an individual. And all those costs can be substantial if you're an individual or you're a small public water supply. They're really not that big when we looked at it in comparison to things like air quality. And the reason is that air quality is valued through ammonia emissions that then form particulate matter, which then causes premature mortalities. And when you start getting into premature mortalities, then you're looking at lives lost, and you're looking at the value of statistical lives, which are a lot greater than when compared to just different treatment technologies. So one of the things that this prompted was to take a closer look at, can we apply these methods that are available for air quality, can we apply them, or should we apply them to things like water quality? So this is where we come to the question of what are the health costs from having elevated drinking water nitrate? And this is tricky because there's an existing standard of 10 milligrams per liter, and but that standard was developed to prevent blue baby syndrome, and it is really effective at that. But there's this growing epidemiological research that's indicating that there are other health impacts that might be possible below that standard. So there's health damages that we might not be capturing there. And furthermore, even if people are aware of these health damages, they still might choose not to treat for them just because of a variety of factors. So avoided treatment costs, even if people are aware of them and want to take actions like installing reverse osmosis or things like that, they might not because it's too expensive. So if they choose not to do it, then we can't use avoided treatment costs as a methodology to value water for people like that. And then all of that leads to how quantifying health costs can be useful for prioritizing investments and identifying burdens on vulnerable populations, because it's not dependent on how much you're willing to pay to buy bottled water to protect yourself. So just to give a really quick timeline of what past work has looked like in this area. It's been going on for a few decades, but one of the earlier papers was this Van Grinsven paper that just looked at the association between colon cancer and elevated drinking water nitrate, and then applied the value of statistical life to that. Since then, people like Bonnie and others have been just adding more and more things on top of that, using different valuation techniques like quality adjusted life years. They've started to characterize the uncertainty. They've expanded it to private and public supplies, and then they've also found other cancer types for which there's an association it's not as strong as with colon cancer, but the association is still there. And then most recently, some researchers are looking into adverse birth outcomes, such as preterm births and low birth weights. So the goal of the work that we've been doing is to bring all of these methods together under one roof and kind of make a generalizable tool that will incorporate them and allow us to really visualize and play with the uncertainty inherent in each of these methods. And we'd also like to make this tool easy to update and tweak the assumptions so that you can, if for a particular policy context you don't want to use VSL valuation, you can look at quality adjusted life years or avoided medical costs easily without having to write a whole other paper and get that published, things like that. So That's some of the motivation for this work. And just a quick side note here, there are two pathways that I mentioned on that past slide, public supplies and private supplies. I'm talking, so private supplies are more vulnerable to shallower wells, there's less testing, there's fewer regulations. So they're an important endpoint to consider, and Bonnie did look at that in her 2016 paper. But there's also a lot less data available on what the nitrate concentrations are. Whereas with public water supplies, there's a lot better nitrate concentration data, but it's still difficult to pin down sometimes what the population served is and who the demographics are. It's going to be the focus of what I'm talking about today, but we are kind of pursuing both of these avenues iteratively and refining them with each project. So I just wanted to give a kind of a graphical equation of what the equation underlying all of these calculations looks like. And it's pretty simple. You start with whatever the MDH says the state or county disease incidence is, and you multiply that by the population served for each public water supply, weighting it by different demographics if it's applicable to that disease. And then the output of that is the expected number of cases of disease within that public water supply each year. So now that we have that number, what we want to know is how many of those would you have had if the drinking water nitrate concentration had been lower or higher? And the way we get to that is with these relative risk factors that come from the literature. They come from these really giant, expensive studies where they follow populations of people for decades, and they correlate, their eating habits with their drinking water nitrate concentrations, and then they look at the outcomes of different diseases in between these populations with elevated, not elevated drinking water nitrate, and they ultimately come up with, a coefficient that lets you say for a given level of nitrate, how many cases, what is the increase in risk for a given disease? So when you multiply the observed number of cases of disease by that coefficient, you get the number of elevated drinking water nitrate attributable disease case counts. And then from there, you can apply one of several different valuation methodologies, like looking at medical cost or value of statistical life. There's not a right answer as to which one of these is best. They use different assumptions, and you have to kind of do that on a case-by-case basis. I just wanted to show this quickly to visualize what's going on with that relative risk value, because it's doing a lot of work and it's kind of a black box. I'm not going to get into all of these studies or anything, but the thing to take away from this is that the red line there is a relative risk ratio of 1, which means there's no association between, in this case, elevated drinking water nitrate and a disease. Now, the blue line is the federal drinking water standard at 10 milligrams per liter. So if you're above the red line, that means that there is an association between that disease and elevated drinking water nitrate. And if you're to the left of the blue line, that means you're in this unregulated territory where you're below the federal standard. So another thing to point out here is that the number of studies backing up all these things is really small. Colorectal cancer has the most with 3, but they are big studies covering very large populations over a long period of time, which is why there's so few. So they're just very expensive and difficult to perform. And one other thing to note on this is that there's a lot of uncertainty. The shaded area is that 95% confidence interval, which oftentimes is on either side of that one line for the relationship for some of these diseases. And that's challenging because we might not ever be able to get really good data on this. There's not an ethical way to expose people to elevated drinking water nitrate and in a controlled way and shrink that confidence interval. So I think that there's always going to be a lot of uncertainty inherent in this kind of work. And it's just a matter of being aware of it and being transparent about it. I just want to show you that same figure that we looked at a minute ago with some numbers attached to it, because I think that at least for me, makes it easier to conceptualize. So this is for the Hastings Public Water Supply in Minnesota, which is a smaller public water supply that has somewhat elevated nitrate. 6.5 milligrams per liter is their long-term average. So well below the federal limit. But when you plug the numbers for this particular public water supply into the equation, you find that, you know, in a typical year like 2017, you might end up with 8 cases of colorectal cancer. And 2 of those might be attributable to elevated drinking water nitrate. And those 2 cases then go on to, you know, depending on the valuation methodology you use, can range from $300,000 to $7.5 million for either the medical cost or the value of the statistical life. When you aggregate those up for all public water supplies in the state, we find that there are 70 nitrate attributable cases of cancer annually out of approximately 6,000 total. And similarly, there's 51 adverse birth outcomes annually. And when you apply the valuation methodologies I mentioned to that, it ranges from 24 million to 231 million for looking at just the medical cost versus going to value of a statistical life valuation. So the last thing I want to talk about is how this all integrates with policy. One of the things that I think is that this work illuminates is that there's some equity implications when it comes to nitrate exposure in drinking water. One, there's a big spatial trend. The map on the left shows just where you have high concentrations of population, nitrate loading, and also sensitive geology. Those 3 risk factors all together. So there's a lot of parts of the state that, you know, this is not so much a problem for them. And in fact, when you look at the public water supplies with long-term average concentrations greater than 3 milligrams per liter, they serve 120,000 people total. So if you were to try to pass on the cost of reducing nitrate concentrations to just the places where it's elevated, you'd be dividing some significant cost among a relatively small number of people. And then, of course, this work excludes private wells, which often are not tested sufficiently. So that's another big source of exposure that's not captured in these numbers at all. And then the last thing is that I want to note is that some research from MDH recently pointed out that high-income households are 2.5 or 2.4 times more likely to install treatment than low-income houses. So my concern is that we'll have this research that indicates that, you know, health impacts are possible below the federal standard, but they're uncertain. And the result from that will be that high-income households that are able to treat, but then you end up with a really inequitable water future because of households without resources don't treat, and because the federal standard is still too high, then the public water supplies don't bring it down as well either. And then this is tangentially related, but I want to flag it anyway because I think it's relevant to this. BMPs are often given as a tool to reduce nitrate concentrations, but some research out of Oklahoma has indicated that, you know, between current climate conditions and, you know, future climate conditions, there can be a 43% increase in nitrate load just because of the changes in timing and intensity of precipitation. And we are projected to see those same changes in timing and intensity of precipitation in Minnesota. So really quickly, just to wrap up everything, estimating the health costs associated with elevated drinking water below the federal limit is possible. It's difficult to do because there's a lot of avoidable uncertainty. And even when you characterize that uncertainty appropriately, you end up with a really large range of values. And that large range of values makes it really hard to argue for changing something like the federal limit. And I'm concerned that because of the uncertainty inherent in this work, there's not going to be a change in the federal standards, and a lack of standards can produce this inequitable water future. So that's why I started this talk with discussion of non-monetary evaluation methods, because I think they offer a useful complement to these economic metrics, which are flawed in many ways, but also still very useful. And I think that each of these methods has a place, and they should really be used to complement each other rather than exclusively using one or the other. So I'm going to leave it there for now, and can take questions in a moment.
Thanks, Ryan. That's that really interesting overview of how to value our water quality issues. It's certainly an area that we need to hear more about. Just a reminder to our audience, if you have questions or comments that you would like to ask any of our panelists or just share, type them into the chat feature of WebEx, and we can grab them from there, or you can, of course, hold them until the end. But you can certainly get a head start and type them into that chat feature as well. Let me introduce our third speaker, Carrie Jennings, from the Freshwater Society. Carrie probably does not need much of an introduction to many of us at the Minnesota Pollution Control Agency anyway. She seems to be involved in just about everything. I met Carrie some time ago when she was mentoring students on contaminants of emerging concern. And she has been involved in a number of things at the Freshwater Society and at the University of Minnesota for quite some time. She joined the Freshwater Society as a research and policy director in 2016, where she applies her understanding of glacial geology and landscape evolution to bridge the gaps between what science provides and what policymaker, watershed district, and local government officials or citizens need to know. She helps shape state and local approaches to manage water, surface water and groundwater, avoid hazards, and use geologic resources wisely. Carrie has a PhD from the University of Minnesota, where she now teaches. She's taught at the University of Minnesota for 25 years, and she has a PhD and master's degrees in glaciology from the U of M and a BA in geology from Northwestern University. Interestingly, she and her husband live on a 120-acre farm, primarily in permanent conservation easement through the Dakota County Farmland and Natural Areas Program. And I also learned that her livestock, I believe, is limited to a dozen chickens, a dog, and a couple of cats. Very similar to my situation. She's also been elected town board supervisor and served on a planning commission for the Eureka Township. As you can see, Carrie applies her training and her skills in a wide variety of ways. Carrie, thanks for being with us this morning.
Thank you, Mark, for going through that whole bio. Let's see, I'm going to share this screen. My connection might be a little slow because I'm in rural Dakota County. So I wanted to talk to you today in a more broad approach about a freshwater future, a 20-year being given a 20-year span of time to think about is quite challenging. No one has a crystal ball. I appreciate Ryan's really targeted talk on nitrate and Alan's talk about drinking water, but I'm going to first restate what I think are obvious issues to all of you at the PCA, and I'm sure that you know more about each one of these than I do, but these are the ones I think currently on everyone's radar screen. Lake eutrophication, with kind of some subcategories of sediment water interactions that are hindering the recovery of lakes by recycling nutrients, how we should prioritize our funding to restore lakes that are currently suffering, what the impacts of a warming climate and more high intensity rain events are going to be on eutrophication issues and the cycling of these nutrients, and then of course the harmful algal blooms that we're seeing increasingly even in lakes in far northern Minnesota. And then the related topic would be just the issue of non-point source pollution, primarily in our agricultural areas, and how we can curb it. I really like the economic argument that Ryan is making to curb nutrient pollution. I also became aware of the role of dissolved phosphorus recently. This is the work of Jacques Finlay's group at the University of Minnesota. They kind of tacked on a phosphorus cycling model to the sediment and nitrogen models that were developed for the Le Sueur watershed. And it's really interesting how much of the load, we assume phosphorus is attached to sediment, but so much of the load is dissolved. Other obvious issues I think that the PCA has been working on include altered hydrology, and this comes from a loss of storage on the landscape for the water that we see. Increasing runoff, even for a given rain event, we're seeing increased runoff, so the loss of storage is significant. This leads to river widening and channel development, channel incision, migration of nick points up higher into the watershed. It's only exacerbated by the changes in precipitation, the high intensity rain events that we're seeing. And then of course, we are continuing to see an increase in drainage across the landscape. So this is only getting worse, and we don't really understand how long it will take a river system to adjust to all these changes in the amount of water that it's being given. When will we see channels stabilize, or will we see channels stabilize? And something I learned about recently is, the other parts of the water cycle that are changing with climate include evapotranspiration from leaves. And that's because CO2 affects the stomata density on a leaf. And we can see a 30% decrease in leaves that we have a long record for, like ginkgo, over the period from the Industrial Revolution to now. So plants are actually changing the way they cycle moisture to the atmosphere as well with climate. And we're also seeing changes in recharge. We don't know if there's a significant impact of tile drains intercepting groundwater and lessening the recharge. Other impacts from high intensity rain events might be decreasing recharge. Of course, land use changes with ET and impervious surfaces is changing the amount of recharge. One of the things that we investigated recently with a group at the University of Minnesota and the Water Resources Center was whether or not it's appropriate to ever consider managing recharge and artificially enhancing the recharge of groundwater. This is something I think of interest to the PCA for one of the scenarios for Southern Washington County PFAS remediation approaches, because it's possible that a lot of groundwater will be pumped out and treated, and this is an opportunity to potentially have that water re-enter the ground. And then when I saw Brooke was on the organizing panel for this, I had to mention chloride. Of course, we want to minimize the impact of chloride to our surface and groundwater and reduce the risk of people who kind of rely on chloride to have safe travel and safe walking environments and finding alternatives. I mean, feels like an intractable problem, but we need to keep trying to wrap our head around it. And then finally, the obvious issues with wastewater, I would say, include modernizing our plants. I mean, I find these dials charming at the Pig's Eye plant, but it just reinforces how old the infrastructure is that we rely on, and the technology that we use doesn't necessarily address these new contaminants that we're increasingly finding. These plants will also have to adapt to increased flows potentially. And then it's probably appropriate to start talking about recovery of resources. And I know there are a couple places like St. Cloud and Madison that do recover phosphorus from the waste stream and create a mineral called struvite, which is a magnesium ammonium phosphate, which is a pelletized fertilizer that doesn't dissolve until it's in the presence of a root. So it's a better phosphorus fertilizer to put back into the watershed. So you can remove the really soluble form, create a less soluble form, and then reuse it and make money potentially. And then since I'm in rural Dakota County, I know where the septage is spread in my township, or in Greenville Township south of me, and it's a disgusting looking field. This picture on the right is how many flushable wipes and other solids come out of the Pig's Eye plant in a given day, 2 dumpster loads like that, at least the days I toured it. And this is the same kind of stuff that's being spread at the surface in rural areas where septic tanks are being used. And I just feel like we're asking an awful lot of the soil microbes to continue these practices that just feel kind of antiquated. So those are kind of the obvious ones, but I think we also have these complex environmental challenges that are are involving multiple steps. It's not a case of simple exposure to a contaminant anymore, where we can use the material safety data sheet and say that, you shouldn't have this much. And it might not even be an immediate human health risk. We might be seeing risks. We might be seeing things show up in amphibians and fish first, and then wonder what's causing them. And these can be very complex biogeochemical processes. There might be steps in the geochemical process where there's a concentration of a certain compound that makes it toxic, or maybe it's animals being exposed at a vulnerable life stage, or there's some amplifying effect of a different pollutant that's going on. Let me give you some examples to show what I mean. And these are straight out of the PCA playbook. This work of Ed Swain and others at the University of Minnesota on the sulfate-sulfide problem in muds in wild rice producing waters, and how iron and carbon and even mercury and the cycling of these in that mud are dependent on the amount of carbon in the mud and the bacteria that are there. This is complicated chemistry, and a standard was proposed based on the amount of carbon for each particular lake. It made sense, but unfortunately it didn't get through the legislature. It just seemed too complicated, and it didn't even really emerge from the PCA in a very healthy form. Another example, you might be not surprised to hear that Mike Burnt and Ed Swain, in their retirement as senior scientists at the agencies, are not just sitting around. They actually approached me with an idea for a talk Freshwater's going to host next month, and it involves nitrogen, phosphorus, and lake eutrophication. Mike lives around Lake Normandale down in Bloomington, where that big ski hill is, and he's really concerned about and has been watching the eutrophication of Normandale Lake, and he also requested the nitrogen information, or the information for the monitoring that's been done on the stream that comes into that lake. And he sees a lot of nitrogen coming off a public golf course, and he and Ed believe that what is going on here is that the nitrogen is actually creating the phosphorus problem. The nitrogen is fertilizing rooted aquatic plants that are rooted in the sediment in the bottom of the lake, and it's the rooted plants that are then dying and causing a release of the phosphorus into the water that is feeding the algal blooms. And so if you just try to work on the phosphorus alone and lower lake levels or do the alum treatments, you're not going to solve the problem because you keep putting nitrogen. So tune in next month for a talk at Freshwater if you want to hear more about their rationale and the evidence they have for this. Another example of a complex biogeochemical process that we really don't understand the impact of would be pharmaceuticals on soil microbes, and how that creates potentially antibiotic resistant genes, and ultimately affects human health impacts human health. And I'm talking specifically about pharmaceuticals used for animals, animal agriculture. So we know that these are the students that I had working for me last summer that Mark referenced. They were College of Biological Science students that wanted to go to med school. I made them think about manure and the impact of animal agriculture on soil microbes, based on the study that the USGS has done about how much of this is showing up in our water bodies. So these are the complex problems. And I want to say another one that is probably on everyone's radar, and that would be plastics. And it's of concern now just because of the amount of plastics in the environment, but also I would say it might become increasingly of concern because as renewable energy replaces oil companies are going to still want to make money off of the oil that they have, and plastics will probably fill the void, or something else created out of oil, and that will now enter our environment. And currently the plastics are everywhere in the aquatic food chain. And we all know about the endocrine disrupting properties of plasticizers, and those are coming with these microplastics. And I attended a talk recently with a Great Lakes research group, or Great Lakes research meeting, and the amount of microparticles in the Great Lakes is just stunning. And it's just hard to wrap your head around. And I think I was reluctant to think about plastics until I heard that talk. But, we have them breaking down physically and degrading to smaller particles and sinking into the sediment, being included in the sediment package, but we also have the chemical properties of the plastics and how those impact the organisms, and then bioaccumulation of some of these in the food chain. And when we talk about microplastics, I think we're talking about the fibers that come off of our clothing, the beads that have been banned but are still everywhere in the Great Lakes, and then just other particles. One of the most common ones in the Great Lakes is styrofoam, little pellets of styrofoam as it breaks, as your beer cooler breaks, blows into the water. So, these have impacts, profound impacts, from just affecting fish physically down to the bio and chemical reactions. I'm also wondering if we need to focus more on these pathways for contaminants. Some of the work of the St. Croix Watershed Research Station shows that, we are seeing pharmaceuticals and other things showing up in northern Minnesota lakes. So how exactly are these contaminants moving from the water to the air to water bodies across the region? This article just came out about how much PFAS is actually in the rain in these different areas around the Great Lakes, Cleveland, Chicago, and Michigan. The concentration is of concern, but how is the movement occurring? And speaking of movement of water, I think we really need to be able to better predict groundwater movement. And this is not just, we can't just look at an aquifer and assume some kind of homogeneous movement of water and contaminants through it. And I know that's not how you think about it. Things segregate with water, but there's fracture flow and other things that affect groundwater movement. And these hydrologic atlases, the part A that created by the Geological Survey and the part B created by the DNR, might not be the solution that you think they are. They really are our first pass. It's taken 30 years for the first pass at the stratigraphy and the general description of the geologic material that we see. That is the focus of the Geological Survey, correlating these units, especially in the glacial section. They also talk about the textures of the matrix for tills. They don't focus so much on the sands and the properties of the aquifers. So these are not site-specific maps, and that's made very clear on the maps. When the DNR samples for the water chemistry, they're really doing this for a general chemistry. How long has this water been underground, and what is the age of this water? So they're not really defining the contaminants that are there. And the sensitivity, the pollution sensitivity, relook at that definition, because this is a rule that was created. I remember the group that sat in a circle in the old Geological Survey library when we were on University Avenue in the early 80s and decided how to define pollution sensitivity. And it's a time of travel definition. I think it's worth relooking at that. This is a recipe that we could probably improve. We really need to understand site-specific aquifer properties of these aquifers, and that would come from assembling the results of long-duration pump tests that we've already done and archiving those data so that they're accessible. There is a database that was designed with great effort, great interagency effort, that is slowly being populated, but there's only one half-time person at the DNR that's currently entering those data. So we're wasting a lot of money doing new pump tests instead of looking back at how these aquifers have been characterized by existing pump tests. And then in the last, I think it's over 1 year, close to 2 years, I've been sitting on the rulemaking panel for construction and demolition landfills. And it just makes me, and we've also been listening a little bit to the Sustainable Building Group do presentations. So that really brings home this idea that we need a circular economy as opposed to better ways to dispose of things. I recently just watched all the Portlandias, and so I love this instant garbage idea, but we have a lot of instant garbage in our world, and it would just be really nice to try to figure out ways to not concentrate these products and dangerous compounds in landfills and at disposal sites, and not rely on recycling of things that are recyclable, but find ways to reuse them. In particular, I think a lot about the increasing use of reverse osmosis systems in homes and where those canisters, those filters end up. Or is it just backflushed into the water, or are there carbon or charcoal filters that are going into our landfills that have higher concentrations of arsenic and manganese than we would like to think about? And in the construction and demolition landfill rulemaking, the main reason I'm on that panel is so that I can just keep reminding people that even if something seems like it's not dangerous, if it degrades in an oxidation reduction reaction, it will change the state of the native material in an unlined landfill and potentially release arsenic and manganese from that native material. And we know from the work of Mindy Erickson and others that arsenic and manganese is a problem, and we need to understand better how it can be released. I even worry about places that I see on the landscape that are big composting piles. You know, what is that doing to the manganese arsenic stability in the till? Speaking of breakdown and disposal of things, I know that there are solutions proposed for PFAS that include incineration at very, very high temperatures, hard to achieve temperatures. If you don't get to the highest temperature needed to completely break it down, you know, what are the incomplete breakdown products that we might be seeing? And then from the good work of the people in Dakota County, we know that if you sample groundwater and measure it closely enough, you know that there's just a soup of cocktail of pesticides and a soup of pharmaceuticals in the water. USGS did the work on the pharmaceuticals. And, you know, what is the impact of having multiple compounds in your drinking water, in your groundwater, on not just you, but on the environment? So we really need better ways to anticipate what our next PFAS is going to be and learn from the past instead of being perpetually stuck in reaction mode. And this, Alan said the same thing in his first talk. I used to think that the societies like Rome that collapsed potentially because of lead in their pottery and pipes were just, how could they not see that happening? How could a sophisticated society come to an end because of some poison that they were ingesting that of their own making? I recently wrote a blog post for Freshwater about the Mayan city of Tikal, where the red paint on the buildings led to mercury poisoning. Recent work of an archaeologist that I heard on NPR. And they were sophisticated. This is a thousands of year old civilization that actually had a surface water capture program from these plazas in the central part of the city, and they filtered it through zeolites on the edge of the city that they had mined and brought in from miles away in the jungle. But their zeolite filters got clogged with mercury, and they ended up leading to mercury poisoning. And then you've all heard of the Mad Hatter and what that refers to. That's just the use of mercury to cure felt, or, you know, this could apply to any toxin that we've used and then learned and decided not to because of the health effects. But, you know, this is a backwards way of looking at it. We think the people out here on the landscape, the people here in Eureka Township, think that your agency regulations are protecting them from everything. They feel that the PCA is looking out for their best interests and will swoop down and find someone who's got a leaking contaminant on their property. And there's a lot of trust there, and there's a lot of misunderstanding about how these agency regulations actually work. Agencies respond to crises, at least so far up until this point. Food and Drug Administration is probably not super proactive about identifying drugs until there's harm. And I have to tell you just a short story about myself. When I was in the 6th grade, I, with my Scholastic book order, accidentally ordered The Jungle by Upton Sinclair because I got Sinclair Lewis and Upton Sinclair confused. And I was horrified about this, but I now understand that, you know, something as bad as, you know, workers falling into meat vats and ending up in the meat products is what led to the Food and Drug Administration and the need and regulations that have created a safe food supply for us. Similarly, not that this book led to the Consumer Protection Agency, but I think people generally feel that, you know, they're not going to buy a product that's dangerous if they have a Consumer Protection Agency, because there's somebody looking out for them, that's keeping them safe. There's a federal agency that tests these things. So who's protecting us from the mad inventors? And the mad inventors might even include scientists at the national labs. And I'm giving this as an example because I have a family member who works at Livermore national lab. He's a computer scientist, and he was partnering with some material scientists who wanted to create chemicals with a certain property. And it was, I can't remember what it was, but it was slipperiness plus something else. And so he was doing the computer analysis and kind of running through the periodic table and all possible combinations of elements to create something that would suit their need. And I asked him, who's thinking about what that compound will do in the environment if it is used and released? And he said, nobody. That's not part of what they're doing. So do we need some kind of federal agency that thinks more about that? An agency that's devoted to the worst case scenario. And I know sometimes it feels like you are doing that at the PCA, and it's a burden. And I really appreciate the work that state employees at the PCA do. But I feel like it needs to be turned around, and we have probably a brief window of opportunity in the Biden administration for a state like Minnesota that's progressive and forward-thinking to communicate with the EPA about different ways of doing things. Once when I was doing fieldwork in northern Minnesota during a presidential election, I heard this speaker that just was, he kind of struck a chord with me, and he was talking about the Department of Peace. Why do we only have a Department of Defense, which used to be called Department of War? Why don't we have a Department of Peace? It was Dennis Kucinich, who of course didn't come close to winning, but I loved his out of the box thinking. And I think that that same thing could be applied to, what we need in the next 20 years or more for a regulatory agency that's based on the precautionary principle. This is not unfamiliar to you probably because the EU does it this way. So we want to prevent harm before a hazard comes into existence. We can't keep playing whack-a-mole and chasing down these contaminants after they're released in the environment. And this is going to make decision-making under these uncertain times of climate change easier also. And, we do have a robust agency structure in Minnesota and funding, as Alan pointed out, to go with it, but it's the opposite of nimble by design. This is a graphic that was created at the DNR when I was there, and it very clearly lays out the different responsibilities for water of the different agencies, groundwater in this case. And it's meant to have some overlapping authority, but these distinct silos where you're in charge of drinking water or you're in charge of industrial pollutants with little crossover. I know there are interagency groundwater teams that are trying to coordinate more, but if you think about it, it's pretty siloed, floor by floor, department by department, and budget by budget. I did see a lot of interagency work happening in the cafeteria, and I do hope that there can be more common ground for interagency reaction or interaction, because the problems now really do require cooperative solutions, and those are being stymied. There was a water reuse task force, I don't know what it was actually called, but I sat on it, and it went on for a couple of years, multiple agencies, including, what's the one about plumbing? Including, I can't remember what that agency is called, but I'd never heard of them before, but they're in charge of the plumbing code. And so, they were trying to figure out a cooperative solution for how we can get more water reused instead of throwing out 100,000-year-old groundwater after we use it once. That resulted in a report that went to the legislature that just died. It's not going anywhere because it's not clear which agency should take the lead, because it is an interagency effort. Another example of this would be the One Health initiative that's actually I learned about from Mark, that's starting at the University of Minnesota, in fact, at the veterinary school. There is a strong link between animal health, human health, and environmental health. We're all sitting on this Zoom because of that, because COVID came out of the animal population and affected the human population. But some other examples would be the prion and chronic wasting disease issue that we're looking at right now. And also what I call pharmaceuticals. I'm probably not the first one to call them that, but the impact of our animal agriculture and the drugs we give them on the soil microbiome and then human health. These are problems that require interagency collaboration and a nimble state government, and we're not there. One of the reasons I think that this is made even more challenging is because, of course, there's a science gap. It's not just a gap in our education system. is being addressed. Standards are changing. We're trying hard, but there is a gap there with these people coming through the system, and the public has kind of science aversion, and you have to, yesterday somebody was talking about writing things at the 8th grade level for legislators and the public. And, that's unfortunate. I think when I go to the legislature and talk to people, there's many, many very bright people in our Senate and House. There's maybe 3 that have science backgrounds of all the elected officials. And so you have to find different ways of communicating science to them. And then I would say that agency staff and leaders, the science capability is even changing. And I don't mean to, I know this has been a deliberate decision in some cases, or it's just who is out there in the job market. But if you make agency science just transactional, if you are just buying the science from the consultant or from the university faculty, if you don't have people in-house that can actually write the contract language, evaluate whether or not you're getting reasonable bids, summarize or review the results when they come in, and summarize the scientific results into plain language, I think it's just lessening the ability of the agencies to do good work. I'm really sad that Ed Swain and Mike Burnt have retired, and I know that there's some other senior scientists that are on the verge of retiring from the agencies, and I really feel like those positions have to be backfilled. You cannot just rely on contracted science. Some other things that I'm going to kind of move to solutions. Some other things that I think you can do out there is you can boost the existing signals and enlist your allies on the landscape. This doesn't all have to be work with the PCA. Increasingly, there's a sustainability coordinator at every college, and we have a lot of small colleges and universities, and every large corporation in Minnesota. And those people are looking for things to do. They're primarily focused on sustainable energy, but they could be deployed to do other things that are on your radar already. Similarly, the Green Step Cities program, you have cities signed up waiting to do things. Make sure that they're doing everything that they could potentially be doing. And then existing certification programs like LEAD have been reviewed and evaluated periodically and upgraded. There must be others. You must know of others. And they could be deployed to have more and more requirements placed on them so that we can perfect, this notion of a circular economy. And then finally, it really all just does come down to the citizens, because they're the voters putting these people in office. They're the ones voting to fund extension of constitutional amendment or not. It really depends on us reaching the people of Minnesota, and we do need to start with the young, but we can't just talk to the kids. And if we can't just have a one-off with the children either, we have to make the experiences relevant and immersive. And Freshwater is now thinking about ways to nurture stewardship through nature-based education in children. That means just being outdoors and learning across the curriculum in the environment. And then shaping careers is so important through internships and mentoring opportunities. We do that in a small way, and I know that you bring on a lot of interns in the summer, and that is a wonderful thing. And I think I saw on the list some of my former students that are here, and I'm really glad to see them. And then when you offer volunteer opportunities, they should be meaningful. They could be just picking up trash, but if they come with additional information and education, I think that is better for engaging and growing this civic engagement. And then I think the connections to consumers need to be made clear. At least, I avoid certain products. You probably avoid certain products because of what you know, but that's not clear to everybody out there. And it might be because product labeling is a challenge. I know that triclosan is banned and was banned initially in Minnesota, or we were the first to do it, but it's still in Colgate toothpaste for some reason. And why is that? And why is it not really prominent on the label? People don't know this. The same with PFAS. We hear a lot about PFAS in the groundwater, but why is it still being used? Why can I still buy pans with it? And why can I still spray it on my suede boots? And why is it in my dental floss? Are there ways to either eliminate these compounds or make work with the trusted professional contacts that citizens have to help them avoid it and have the groundswell come from the consumers. I think that might be my last slide. Yeah, I think that so in this category, it's if we can just better communicate risk to the public in the way that Ryan did in his talk, I think we will have a lot more grassroots support and civic engagement. So I'm going to end there. See if I can stop sharing. There we go.
All right, great. Thank you, Carrie, and thank you everybody for sharing your expertise with us. I do see a couple of questions here in the chat, so I will go ahead and read the ones we have. And those of you out there in the audience, please add in any of your questions. They don't necessarily have to be questions. They can be just thought-provoking suggestions or any kind of commentary you want to add to the discussion here. We've got one here for Ryan, it looks like. This is someone who supervises the Health Risk Assessment Unit at Department of Health, where they develop health-based water guidance values for chemicals and groundwater. Sounds like they have struggled with how to value many of the nitrate epidemiological studies due to a variety of issues. And they are curious about what process your group uses to evaluate those epidemiological studies.
That's a really good question, and something we have also struggled with and are continuing to struggle with. So the short answer is we're still figuring out. The estimates that I showed were, a really simple mean of all the studies currently in our database, but we have some plans of things to enhance that a little bit. But in order to be included in the database in the first place, the study has to have a relative risk value. It has to have a 95% confidence interval for specific outcomes. It needs to have quantitative data on nitrate exposure measures, and then also data on the average concentration and or intake of drinking water nitrate. So if it has all of those things, like when we apply all of those filters to the studies that we've reviewed so far, we end up with 34 total studies. From that, there's still some work to be done. So within that, there's case control studies, which are faster and cheaper to implement, but they're not as good as these cohort studies, which take decades to apply. So one of the things that we're exploring is weighting those cohort studies more heavily when we're coming up with our relative risk values that get applied to the health cost equation. The other thing that we're working on still is that all of these studies use a different range of nitrate concentration, like 3 to 5 parts per million, 4 to 10, something like that, which does not map neatly onto the continuous data that we get from NDH of what their long-term average is. So we need to come up with some way of translating all of those different buckets into a continuous function that we can then apply to the raw data that's coming in. We're still working on the best ways to do that, and I'd be happy to talk about that more with your group.
Great, thank you, Ryan. We have another question here, and you can use Q&A or chat. I can see comments on either of those, whichever you pick. We will make sure to get your questions answered. This one's for Alan. Do you see movement within EPA toward an enforceable standard for manganese?
Well, that's a great question, and sort of my answer is yes and no. I mean, it's on their radar screen. We've had conversations about them with it. I think they're going to evaluate it in the next cycle of evaluating contaminants off the CCL and doing rate determination. So they just did the latest cycle late last year and then reconfirmed it in February. So they really have another 5 years to do that. We've had internal discussions within ASDWA across the state, and it's kind of a mixed bag. There's a lot that want to do it because the health advisories aren't necessarily helpful in forcing the systems to do something. But there are other states that just feel like they're overwhelmed with the lead and copper rule and PFAS and would prefer to push it off for a while. So we've kind of got a mixed bag, and we haven't been able to land on a crisp ask. I do think it's one that warrants and interesting here in Ryan's discussion about how you interpret epi studies, because that's I'm a trained civil engineer, so my expertise on that is non-existent. It is challenging, and so there's a fair amount of information on manganese, but hearing about nitrate, it makes me think, well, maybe we need to be thinking about nitrate also. And so the short answer was yes and no, and it kind of went on for a while. So.
Great, thank you, Alan. We have another question for you. This is from Katrina, which I might need her to unmute and finish her statement here, but I agree that TCSA reform is badly needed. How can states, federal entities, and organizations like ASDWA implement those changes, I'm going to say?
Yeah, okay. This is Katrina. I had to leave the call to work on the legislative budget, and I was like mid-thought, and then I realized there's still 2 minutes left. So just Alan and others, I do see like momentum that may have not been there previously related to TSCA reform, but I'm just wondering if you have thoughts about how we can work across organizations to really drive this forward, and where you would suggest we start, because it's just such an elephant that is now ancient and needing so much work. How can we focus our initial momentum?
Yeah, I think I would recommend contacting the new or working through the office of the new assistant administrator over at TSCA, Michal Friedhoff, who was formerly over on Senate EPW. We had a meeting with her and some other water organizations last week, a week ago Monday. Very optimistic, better words and proposed actions that I've heard coming out of the TSCA office than ever in my 30 years in drinking water. They're going to take a relook at 1,4-dioxane, and that's one that right off the bat that they rushed it out last year. And now they're going to relook at it. So I'm optimistic, and I would recommend trying to work through Michal's staff and get a conversation with her. It's nice to hear directly from people with I say boots on the ground, kind of thing, and that's why I think they appreciate that. And then I would also do what you can to contact your members on the Hill. That's also another way to sort of work it. But I think right now Michal's the step one, and two, the representatives in Congress and senators.
Great. Thank you, Alan. I just want to also make sure, I'm not sure if our panelists are seeing the chat, but Sarah with Department of Health did share her contact information with you, Ryan. So if you haven't seen that yet, she did put her email address in the chat for you to hopefully talk about things later. And right now, I'm not seeing any additional questions or comments in the chat.
I have one for Carrie, actually. This is Mark. Carrie, from your vantage point at the Freshwater Society, you have the vantage point of looking at what's going on in research and what is going on in policy on kind of that granular level. And you also have the advantage of seeing through the work that the Freshwater Society does, its good work, getting the pulse of the public, and where the public is, and where where we may be missing the mark in engaging the public. And you referred to some of that. I think actually all of you referred to some of that in your talks. Can you, in just a few sentences, I guess, give us a sense, how much are we talking to ourselves in the technical community? And, how much should we be reaching out the other way and engaging people a bit more to make them aware of what's going on? I mean, is that a bigger issue than we're aware of on the technical side of things, do you think?
I think that might be a bigger issue. I think and again, I can only refer to my public here in Eureka Township or the Freshwater public, but they do feel like that the PCA is a regulatory body. They understand the rules, but they also emphasize how well protected they are. So when I'm going to refer, I know Jill Trescott is on the phone. I saw her on the call. I'm going to refer to something she did and Dakota County did for each of the townships and maybe the cities too in Dakota County. When they got the results of their studies of groundwater sampling, they showed up at town board meetings and explained them to the town boards. So they showed which areas had high manganese and which were potential arsenic risks and where the multiple incidences of pesticides occurred in the wells. That was really important. And even the people who don't understand the technical information maybe started testing their wells. We also engaged the public in Dakota County. Freshwater did through, they wanted to update their groundwater plan in Dakota County, the 10-year plan. And so one of the ways they drew people into those meetings to just talk about groundwater was to offer free testing opportunities. And people came in with their well samples and they were concerned about nitrogen in their groundwater and other things. So I think the more opportunities that people have to actually approach an agency like the PCA and air these questions, and you might have to lure them in, but I think they need to be individually approached.
Yeah, those are some really interesting ideas. I do have one more question. If there's no others in the chat box, Brooke, from other people, or are there? I see one over there.
We have one that just popped up. And this is about triclosan in toothpaste, saying that triclosan is in toothpaste because it is effective in treating gingivitis. MDH Health Risk Assessment Unit has an information sheet for triclosan in which we recommend that individuals not use products with triclosan unless they have been advised by their health caregiver. And there's a link there for that guidance if anybody is interested in checking that out. So thank you for sharing that.
And that's wonderful to have. And it probably should be in the hand of every dentist and every, who are the people that treat your gums, periodontist, because they're the ones that are going to be communicating that risk or that need to their patients. And maybe it is, I don't know.
Great. So
Alan, one of the things I'd like to circle back to just real briefly is, going back to that paper that I referred to in introducing you initially, that I thought was really so good. At the end of that, you said, do we have the tools? You asked, do we have the tools to, look at the upcoming issues or something like that, the upcoming problems that we're going to be facing in water down the road, and looking at how the EPA adds its contaminants of concern to the CCL and how it rather ponderously goes through that list. Do you think that needs to be radically changed in how the EPA addresses those things in terms of funding, in terms of considering those things, or, is it about as good as it's going to get?
I think it's a blend of both. I think the radical part would be the funding because they've been flat for 20 years. And so again, that's really, and in talking to their staff, they just don't have the bandwidth they did even, 10 years ago when that paper was written. We're actually coming up to the 25th anniversary of the 96 amendments in August, and they've been flat for 25 years. So I think the funding needs to change. I think the principles are solid, and there have been some tools the last 10 years. The process that Minnesota's used to prioritize. There's a graphical approach that I wrote with a professor and a couple of his students to try and be able to sort through 100 or 200 contaminants, as well as a concept by another colleague, Chad Seidel, on a risk cup and a relative health indicator. So we're getting some tools. We just need some bodies and funding to sort of implement them. So I think the process of DPS, it really needs some focus on how to speed it up. I think the fundamentals are solid, but how can we speed it up? And that's how I would characterize it.
And I would imagine that the different focus that different administrations inevitably bring changes your fortune in a fortnight.
It could.
And-
I mean, we're talking
Yeah.
about significant budget increases, so we'll cross our fingers and see how it goes.
All right, well, I'm not seeing any additional questions or comments in the chat or the Q&A. So I think we can wrap it up here. And I just wanted to thank all of you for the time I'm sure it took you to pull together your very informative and interesting presentations, and for taking time out of your schedule to be with us here this morning, virtually, albeit, but it's still great to share your expertise with all of us, and we really appreciate your time. It's been a fantastic, I think, session. And thanks to Mark for this great idea of pulling together and doing things a little different. We decided we might try this again in another couple of months. So maybe every 6 months, we'll have a group of panelists on some important water topics. So thanks for Mark for all your hard work pulling these great speakers together and getting us set to have a really great talk today. So
well, it has been really fun to do, and as usual, you know, I learned so much just by listening to our different experts that come in, and today has been no exception. Alan, thanks for your time and willingness to participate in this. Ryan, thank you for stepping into the gap, as I said earlier, to take over for Bonnie on short notice. It was a great presentation and really learned a lot. Carrie, thanks so much for your perspective on things. It was really the kind of consortium that I'd hoped that we would pull off. Thanks again.
Thanks, everybody.
Thanks. Bye-bye.
Thanks, everyone.
Thanks, Brooke, for